Okay, paper 2, question 10. Let's draw a graph of this function that we're given, and we're told that it's 3x to the power of 5 plus 2x plus 5. There we go. Now, my diagram doesn't quite look like theirs, so we need to change the axes slightly. Let's just hide that label. It's going to be a little bit distracting and in the way. What I'm going to do first of all here is grab hold of the axes and hold down the shift key, and that way I just change the x-axis. Go back and grab it again. And I'm going to keep my finger on the shift key and move it down like that. So now I can see my function as the diagram has given it to us. Now I'm being asked to work out the coordinates of q, which is going to be that point there. So what I can do is I can go menu, trace, and menu, analyze graph. No, let's do trace and just do graph trace, and if I can see straight away that the point 0, 5 is where we started at. Now I can go left, 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 left and scroll on down and find the coordinates of p, which seem to be -1, 0. So easily enough to get the two values which we're going to need for parts A and part B. Another way of getting the coordinates of P would be to, I'm just going to insert a new page, Control Doc, and I'll enter a calculator, and I'm going to try and find the zeros of my function f. So I can do menu, algebra, polynomial tools, and real roots of the polynomial. I'll press var to get f1 of x, and put a comma x, and I get the x coordinate of P there. Alright, lots of ways of going about getting that intersection with the x-axis. Alright, so I'll just press escape to get out of trace mode. Now, part C we can't do, that's an indefinite integral, but then it's wanting the exact value of the area between the regions. And so what we can do is simply do evaluate on my calculator page. I'll press the template button, I'll go to definite integral, and we're going to go between the x-coordinate of P, which we just found out to be -1, and the x-coordinate of Q, which was 0. The function, we can just press var and choose f1 of x, and that's simply what we're going to be asking for us to do. Pressing enter, I get 3.5. I'm guessing 3.5 is a little bit like 3.5, but what I can do is I can do menu, number, approximate that to a fraction, and I get 7/2. So no awkward numbers there really to deal with. That should check anything you've done by hand. Part E we can't do, it's a volume of revolution, unless we're going to get a decimal, we're going to get awkward numbers involving pi's, but we're going to rotate that around with pi. So I'll just press the pi button and then press enter, and then times the radius squared, so it'll be f1, move to the outside, squared, like so, and I'll get an awkward number like that. And if we were trying to figure out it wouldn't be pi r squared. Yes, it would be pi r squared. We could remove the pi from the outside just to get that. Again, that's nothing particularly nice. Maybe we can convert that menu, number, approximate it to a fraction. Not looking particularly nice. Sometimes what you can do is reduce the accuracy down to, say, 8 characters. Still not looking nice. So I got 3203 all over 231 multiples of pi. So if I do that number multiplied by pi, I'll get the same answer I got before. So that's one way of getting the volume of revolution, from simply doing pi r squared. Okay, carrying on to part F. We're going to do the definite, we can't do the definite integral, but what we could do is write down what we think it is and check it graphically. So you may think, let's just insert a new graph page, that's the quickest way of doing it. And what I'm going to do is I'm going to templates, I'm going to choose the derivative template, and simply do the derivative of pressing var will give me f1 of x. And that's what the derivative will look like. I may have done it by hand, and I may think I know what it is, so just by pressing the tab key I could type in, say, 15x to the power of 4 plus 2, and if this is correct it should sit on top of that red graph, and it does. So you may have done it algebraically, and it's a way of checking your answer if nothing else. Now for part G, I need to get the gradient of the line, and it's the gradient, and it's parallel to the line that goes through P and Q. So let's go back to my original graph. P is there, Q is there. The gradient of the line, it may be obvious, that's -1, that's 1. We're going 1 along, 1 up. It's going to have a gradient of 1. We could check that if we wished. We can do menu. Let's go to geometry. We'll do points and lines and choose line. I'll go through that intersection point there. And I can't quite fix it unless I can. Now I'll just put a point on there and then press escape. I can go over that point and pull up its coordinates by pressing control menu and then edit the x coordinate to be 0. And then this line here, what I can do is I can measure its slope. Let's see if I can do that. Measurement, I can get its coordinates in equation, and I get y equals 5x plus 5. Which, there of course, yes, because that's -1 all the way up to 5, so it's actually got a gradient of 5, not a gradient of 1. It was good that we checked that. So a line that's parallel to that will also have a gradient of 5. So if I go back to my calculator page, where was it? There it was there. What I want to do is I want to find out when the derivative of f1 of x is also equal to 5 to get the point t. So to work out where the derivative is, I can do d by dx of f1 of x, and I want that all equal to 5, and I want to solve that for x. So what I need to do is press menu, algebra, numerical solve that expression for x, and there's the x coordinate of point t. And now I need to work out the y coordinate of that, and that will simply be f1 of the x coordinate, which gives me that. So we have approximate coordinates of t to be 0.67, 6.74. If we're going to go to 3 significant figures, it should be 0.669 and 6.74. Now, what we can do is, can we plot that point? No, but we can probably see if it's at least valid. We can go back to the graph, and I'm going to draw the line that's parallel to that. So menu, geometry, construction, a parallel line to that line, and I'll put it on the graph there. Let's press escape. And if I just get the coordinates of that point by pressing control menu, like so, I can move things around. Now you can start to see that the coordinates which I'm after a negative x coordinate. There's clearly another point over there with a positive x coordinate, and that's the one we found by mistake. So what we need to do is go back over here and search for values of x which are negative. So let's go to the calculator page. Let's just re-execute this nsolve command, and I want to go for control equals given, and I'm looking for x to be control equals less than 0. And press enter, and now I get the value which I'm after. It's negative 0.669 to 3 significant figures. And again, we can work out what the y coordinate for that is by doing f1 of that value we just got, and it works out to be 3.26. Let's just go back to our graph and just check if that's looking fine. Well, it says 3.26. Well, obviously we haven't quite got it quite right, but 3.26 looks very plausible. If I wanted to be very precise about this, I could store that negative 0.6 into a memory. Let's store it in t. So t is defined as being equal to that value there in all its glory. If I go back over here, if I edit the x coordinate, just type in t, it plots it exactly and resubstitutes the values. So we got a nice graphical confirmation of what we've done algebraically, and we discovered there could have been a red herring route we might have followed. And so now we're being asked to work out the area of this region between the original curve and this straight line, which was y equals 5x plus 5. So what we're going to do is we're going to go to a calculator page. We're going to do a definite integral, and we're going to go from the value of -1, that's the coordinate x coordinate of p, to the x coordinate of q. Looking at the calculation we've got to do here, we're going to have to do one function subtract another. So press the var key. There's my first function, and I'm going to take away, I'm going to be really careful about this, put it in brackets, 5x add on 5. That's the coordinate, that's the function, sorry, of our straight line. and we'll just tab out to x, and this will give me a total area of 1. And this question is now complete.